Welcome back to Let's Launch. In this video, we'll talk about the latest version of the Spacex Starship. This is an amazing rocket bigger than the Saturn V and will hopefully launch soon. More specifically, we'll talk about the design. By the way, in the previous video, we talked about the evolution of the Spacex Starship, and in case you're interested, it'll be in the top right. The design will be split into two videos, and if you're wondering where you can find the second video, it will be either in the description or at the end of the video. Let's get started. The current version of the Starship was designed to be fully reusable. It is an orbital rocket with a goal to lower launch costs. The rocket contains a Super Heavy booster and a Starship upper stage. The craft uses two versions of the Raptor engine, normal and vacuum optimized. The two stages are made of the same material, SAE 304 stainless steel, which also happens to be the most common version of stainless steel. When the craft is fully assembled and fueled, it weighs 5 kilotons. The craft is 120 meters tall, along with 9 meters in diameter. It is actually taller than the Saturn V. Super Heavy's max thrust is 72 meganewtons. By the way, 72 meganewtons is enough to hover more than 7.3 kilotons. Even with all the thrust at liftoff, its thrust to weight ratio is around 1 to 1.5. Because of its lift capacity of 100 tons to low Earth orbit, it is classified as a super heavy lift launch vehicle. The Starship is made from rolls of steel which are cut and shaped to have the 9-meter diameter. The Starship uses rocket engines known as the Raptor engines. They are amazing methane-fueled rocket engines. They operate at a tremendous pressure of 300 bar, but in tests has even gone up to 330 bar. 300 bar is the same as 300 times the atmospheric pressure, since 1 bar is the same as the atmospheric pressure. Since they have to withstand tremendous pressure, they are made of a special alloy that SpaceX developed themselves. The cost for a single rocket engine is $230,000, but the thrust they produce is also a lot. In fact, it has reached up to 1.8 meganewtons for the Raptor 1 or 2.3 meganewtons for the Raptor 2. That totals to around 1 kilonewton per $100. That means per $100 it costs, it produces 1 kilonewton of thrust. The Raptor engines are said to run at an oxygen to methane ratio of 3.5 to 3.7 to 1. This results in a slightly fuel-rich combustion, meaning there is still some energy left. The most likely reason for this to be done is to lower the temperature. If it was burned at the 2-to-1 ratio, which happens to be the most fuel efficient, the engine would most likely overheat, melt the tubing, burst the fuel pipes, and be an overall disaster, which would probably result in an explosion. The engine's exhaust contains water, carbon dioxide and monoxide, nitrogen oxides, methane, oxygen, and hydrogen. The engines are the only full-flow staged combustion engines that are currently being made. In the past, the Soviet Union and the US tried to make such engines. They succeeded, but they were never put in a rocket, unlike the Raptors, which have already been installed in multiple rockets, including several which have been flown. Of course, not to orbit, though. A full-flow staged combustion engine has two preburners for the two fuels, which are connected to their turbopump counterparts. They are fed by two different fuels. One of them is fed with a touch of fuel and all the oxygen, while the other is fed by the opposite, all the fuel and a touch of oxygen. Of course, as I say all, I mean all but the touch which has gone to the other preburner. This spins turbines and pumps fuel back into the preburners. The exhaust of the preburners is then fuel-rich or oxygen-rich, meaning it has a lot of it. This then can be burned to the main combustion chamber for thrust. For more information on stage cycles, I'll leave a link to a video by the Everyday Astronaut. That's it for this video. Thanks so much for watching. If you enjoyed the video, please consider subscribing as that'll let you see when the next video comes out. The rest of the design will be in the next video, which, if it is out, will also be in the top right corner. Some other videos that you might enjoy will be on screen.